Once again, good morning and welcome to our math class. Today we will be learning about radicals. Now, what is a radical? You see this sign here in your calculator? That is an example of a radical. That's why it's our cover photo for our lessons this time. Let's start by reciting today's memory verse. And it's found in Luke 6, verse 27. We'll be talking about radical love. It says, "But I say to you who hear, love your enemies, do good to those who hate you." And today's MVCA boosters is related to this. It says, in what ways can we show radical love to people around us? At the end of today's class, we'll be able to write expressions with rational exponents as radicals and vice versa. And the second is we'll be able to derive the laws of radicals. So let's start. Now, that will be our sample for our venture activity, but we'll go back to that after we discuss the first part of the lesson. Now, you see the pattern, 3 to the power of 2/3. You see, where do you see the exponents numerator? Here. Where do you see the exponents denominator? This one. How about the second one? Let's check. Where do you see the exponents numerator? And where do you see the exponents denominator? Yes, AP, you raised your hand.
Ma'am, yesterday we did this with our tutor.
Okay, then.
We already know this part. I already know this part. The denominator goes outside and the numerator goes inside with the number.
Oh, very good. Now, can you share with us what you learned for number 3? How will you write 5 to the power of 3/4 in radical form?
Okay, it's 5, then the 5, then the kanayang check, the radical.
This one, what will you place here?
Wait, no, wait. It's actually 4, ma'am. 4.
4 outside. Okay.
5, then 4 is outside, then 3.
3 is here inside.
4.
Okay.
Yeah, 3 is
like
inside.
This one. Okay, very good. That's a very good answer.
The answer of that is 4 radical 5 to the power of 25.
3.
4 radical 25.
25,
That's
but it's
answer.
3 here. It's 3. So that should be the
125
of 125.
125.
Okay, very good.
That's it.
Now, let us have the parts of the radical expression. What are the parts? Here, this one, the one that AP called check. It's not a check, okay? This is called the radical sign. This is a radical sign. The one inside is called radicand. And the one with the N is called index. Now, how do we read expressions like this? For example, if the index is 2, like this one, we don't write 2 anymore. So if there's nothing written here, it means that the index is 2. How do you read it? You say square root of 4. Again, square root of 4. What if we have 3 in the index? We say cube root of 4. What if there's 4 in the index? We say fourth root. Fourth root of 4. What if we have 5 in the index? We say it's the fifth root. What is the fifth root of 4? That's how you will read it. Now, what's the relationship between the rational exponent expression and the radical exponent? Here, just like what AP mentioned a while ago, for a to the power of mn, the exponent, the numerator, will go with the radicand. So it's a to the m power, or it can also be like this. There, any will do. Again, the exponent remains as the exponent, the numerator, with a radicand, while the denominator becomes the index. But here, if n is even, if our index is even, then a, our radicand, should be a non-negative number, or else it becomes imaginary. Remember, square root of 16. The answer is plus and minus 4. But if we have square root of negative 16, the answer becomes imaginary. So if the index is even, our radicand must be positive. But if the index is odd, our radicand can either be positive or negative. Why? Example, we have negative 2 times negative 2 times negative 2. The answer is negative 8. So if we are looking for the cube root of negative 8, like this one, what should be the number when multiplied thrice by itself will give you negative 8? Then the answer is negative 2. Or if you just have positive 8, then the answer will be positive 2. So again, if the index is even, our radicand must be positive. If our index is odd, the radicand can be negative. For example, let me give you some expressions with real roots. Here, even, positive. Even for the index, positive. Odd for the index, positive. Odd for the index, negative. It's okay. Now, why are these not, why do these expressions will not have real roots? You check. Even, so this must be positive. Even, so this must be positive. Even, this must be positive. And even, this must be positive. Again, when the index is even, the radicand must be positive. But if it's odd, no problem. Any radicand will do. Now, let's try to write the following expressions into radical expressions. Now, you could not write it in the chat box anymore because of the sign, but let me assign, okay? Ready? Okay, AP will do number 1 based on my screen. Jared will try doing number 2. Then Tatiana will do letter C, Again, AP, letter A. Jared, letter B. Tatiana, letter C. The next one, for letter A, let's ask Faith. For letter B, they asked a while ago, we have Janine. And for letter C, let's have Ali. Okay. A for Faith, B for Janine, C for Ali. Let me go back to the first slide. Now let's start by rewriting rational expressions to radical expressions. Again, for the exponent, the numerator will go inside, while the denominator will go to the index. Now let's start with the first one. Ready? We have square root of 81. Now we need to find the principal root. What do you mean by the principal root? Remember when we have our answers in chapter 1, it can be positive or negative. This time, let's just take the positive sign. So our square root will be 9. So the answer for number 1 will be 9. Rewrite, then simplify. Next, let's go to number 2. For number 2, like what Jared shown us, the numerator of the exponent is 1. So no need to write 1. While the denominator is 3, it goes to the index. This is how we rewrite it. Now, how do we simplify it? You listen. You find a number that when you multiply by itself 3 times, the answer is 64, or a factor of 64. I suggest you start with the small ones. Example, 2 times 2 times 2, 8. Or 3 times 3 times 3, 27. Let's go to 4. 4 times 4 times 4. The answer is 4 times 4, 16 times 4 is 64. Therefore, the cube root of 64 is 4. Since there is an answer, a definite answer for that, then we place 4 outside. Okay. Let us see if there will be anything left in the cube root inside. Next, for x, what do we do? How do we find the cube root? We divide the exponent by the index. If the answer is a whole number, it goes outside. But if the answer has a remainder, the whole number will go outside, the remainder will remain inside. Example, 3 divided by 3. The answer is 1. So the exponent for x is 1. Next, for y, 6 divided by 3. The answer is 2. So the exponent for y is 2. There's no remainder, so we erase this one. Nothing left inside. So the answer is 4xy squared. Let me give you another example. Let's find for the cube root of y to the 7th. How do we simplify it? Okay, 7 divided by 3. The answer is 2, remainder 1. So we place 2 outside, y squared. But there's a remainder of 1, right? What will happen to the remainder of 1? It will be left inside, remainder of 1. So the answer will be y squared cube root of y. How about the next one? Ready? The denominator will go to the index. The numerator is 1. No problem. Now, negative, it's okay because our index is odd. What number, when multiplied by itself, will result to negative 27? You have here, right? 3. But since our answer is negative, or radicand is negative, then our answer will also be negative. So the answer is negative 3. Any questions? So let's have more practice, okay? Let's go to the next one. How do we write this? Ready? Let's start with the index. Index is 2. It's okay not to write it. Or whether you could write, it's okay also not to write. 9, negative 3. How do we make it, ma'am? Let's do it this way. It can be to the power of negative 3. That will turn into 1
2 to the
over
radical.
9 cubed. Okay? Now, how do we solve that one? Ready for this one? Let's start. Wait for a while. There. This can be written as square root of 1 over 9, then to the third power. That's the same. Now, let's move one by one. What is the square root of 1? What's the square root of 1? It's 1. What's the square root of 9?
3.
It's 3. Very good. So 1/3. Now, cube it. The cube. So 1 cube is 1. 3 cube is 27.
27.
3 times 3 times 3. So the answer is 1 over 27. Questions?
No, ma'am. I
Okay,
got it.
next one. Okay, let's make this positive. 64 to the 5 over 6 power. Let's start. The denominator is in the index. And 64, then to the 5th power. I suggest you do this one later, the 5th. Place it outside. Yes.
Ma'am, it's negative 5, man.
Yes, but you see, I transferred it on top. Here, from the denominator, I made it to the numerator to make it positive.
Okay.
To make the exponent positive. So let's now solve. What's the 6th root of 6? I suggest again, we start from the smallest number. So we have 2. Multiply 2 by 6 times by itself. 1, 2, 3, 4, 5, and 6. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. So the 6th root of 64 is 2. So we're done with this one. But there's to the 5th power. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2. The answer is 32. Any questions? Let's go to the last one. Ready? Okay. Ali wrote it first in the denominator to make it positive. The next one. Okay, we can also write it this way. The fifth root of 1 over negative 243, then square all. Why square? Because the numerator is 2. Now, since this is a fraction, possibly our fifth root is also a fraction. What's the fifth root of 1? It's still 1. The denominator is negative, so the answer will be negative. Fifth root of 243. We know it's not 2, right? Because the fifth root is 32. Let's try 3. 3 times 3 is 9 times 3, 27 times 3, 81 times 3, 243. 1, 2, 3, 4, 5. Very good. So negative 3 to the power of 5 is equal to 243. So the fifth root of 243 is 3. But since it's negative, so we'll also have negative 3. Then we square it. 1 squared is 1. Negative 3 squared is 9. So the answer is 1 over 9.